Hi, everyone, and thanks for joining me for episode 772 of People Behind the Science. Today, we are resharing our interview with our guest, Dr. Bryan Fry. Listeners, Bryan studies the evolution of venomous animals over time. His research also examines how we can use venomous substances as physiological probes to learn about disease states and in the development of potential therapeutic agents. In our conversation, Bryan shares wonderful stories from his life and research. So I hope you enjoy this episode of People Behind the Science.
Every day, discoveries are made that will change our understanding of the world around us. Dr. Marie McNeely is here to bring you the brilliant minds who are making these discoveries so they can share their incredible stories and take you on an amazing journey. Welcome to People Behind the Science.
Hello, everyone, and welcome to another episode of People Behind the Science. Our wonderful guest today is Dr. Bryan Fry. So, Bryan, welcome to our show. How are you?
I'm doing very well. Thank you very much for having me.
Well, we are excited to hear some of your stories and to have you on our program today. But I want to take a moment here before we dive in to introduce you to our listeners. Listeners, Bryan is an associate professor in the School of Biological Sciences at the University of Queensland in Australia. He completed his undergraduate training in molecular biology, scientific philosophy, and psychology at Portland State University, and he received his PhD from the University of Queensland. Afterwards, Bryan worked as a research assistant at the University of Melbourne, and he was awarded a postdoctoral fellowship to conduct research at the National University of Singapore. Next, Bryan returned to the University of Melbourne as an Australian Research Council postdoctoral fellow, and he was later awarded an Australian Research Council Queen Elizabeth II research fellowship there at the University of Melbourne. Next, Bryan was awarded the ARC Future Fellowship at the time that he joined the University of Queensland, and he is there at the University of Queensland today, still conducting phenomenal research. Now, Bryan was the recipient of the 2011 Fenner Medal from the Australian Academy of Science for his research, and he is a member of the elite adventure society, the Explorers Club. In addition, Bryan has been featured in documentaries on Animal Planet, BBC, the Discovery Channel, and National Geographic TV. He's also an author of numerous articles, as well as 2 books. And I want to give a shout out to your 2 books, Bryan, the textbook Venomous, Reptiles, and Their Toxins, as well as your memoir, Venom Doc. And listeners, Bryan is here with us today to talk about his phenomenal research and tell us about some of his own experiences in life and science. So, Bryan, today we want to get to know you both scientifically and personally. So can you start by telling us what you like to do with your time when you're not doing science?
Well, like most scientists, science is kind of a passion, not necessarily just a career. So it permeates through all layers of my life, which naturally can be a little bit hard to separate. So like if I'm not in the lab, I might be out doing a big bushwalk with my wife and our 2 dogs. But of course, I'm still looking around the natural world and marveling at all the wonders around and thinking about ideas. So it's one of these things of where I almost never stop doing science, which can be a little annoying for my wife. Mm-hmm. It infuses every aspect of my life. And that's, of course, a very common characteristic about scientists is that amazing passion, this deep and abiding love and wonderment for the natural world is what becomes the fuel that allows us to drive through the incredible emotional roller coaster of lab research, amazing amount of drudgery of administratia, as well as the uncertain career paths and the incredibly frustrating drip feeding nature of science around the world as far as the funding side of it.
Certainly. And I know as part of your research, you have a lot of these high adrenaline moments studying these venomous creatures. Do you have this high adrenaline desire in your life outside the lab as well?
Yeah, I've always been the kind to do rock climbing, big wave surfing, skydiving, all the activities that make insurance companies cringe.
Of course. Well, fantastic to hear a little bit more about your life outside the lab, but I do want to hear a little bit more about your scientific side next. Bryan, can you tell us what is this high-level description that you usually give people when they ask you what you do?
Well, what I work on are venomous animals. So I'm personally very interested in the evolution of them, of how things have changed as continents have collided, animals have gotten trapped on islands, or new prey become available, or prey become extinct and then animals switch. So these kinds of dynamic processes through deep time is the thirst for my intellectual curiosity. But of course, we look at the applied side of it, of how can we use these kinds of toxins as physiological probes to teach us more about how a particular ion channel might function and therefore explain a bit about a particular disease state, and can they ultimately be used as, if not intact, then a modified synthetic analog as some sort of therapeutic agent.
Very cool. I'm excited to hear more about these projects as we go through our conversation today. And you mentioned your passion for science percolates into various aspects of your life, which makes it sound like you're really motivated to go in and do your research. But I love hearing a little bit more about what motivates people. And do you have a particular force that drives you every day, or maybe a saying or a quote that you keep in your mind?
Never give up, never surrender.
I like it. That's a good one for science.
Yeah, it is. Because it can get very frustrating, ranging from having grant applications knocked back, that science funding globally is undergoing an extreme crunch. We have a hard right government here in Australia. There's a hard extreme right government now in the UK. And of course, we know the debacle going on in the US, where science funding is not exactly going to be a priority. And it's not just today's governments. These are symptomatic of the much more fundamental problem where it's well established that for every dollar invested in science, there's $7 that comes out, but that $7 can take 15, 20 years to eventuate, while political cycles are, of course, measured in a matter of just a couple of years. So your typical politician, upon getting elected, the first thing they do is start planning their re-election. So they need short-term, shallow, populist slogan type, quote-unquote, accomplishments rather than things that it will actually make a significant change. And that's assuming that they even want to make a change, that things like climate change and the environment are under constant attack through the same political playbook that was mastered by the tobacco industry.
Certainly. I think some of these frustrations are mirrored in science as well. You said the one thing about having to start as soon as you kind of get a position, starting to plan for the next one. I feel like the same thing can be said for grants. It's always a challenge. You feel like as soon as you get one, you can maybe breathe a sigh of relief for a few moments, but then you kind of have to get back into it. So
I'm a little disheartened at the moment where I actually went 0 for 6 this year for grants, including one that was a application to follow up on some work we did on the long-glanded coral snake that 2 weeks ago, this work actually went viral when the report came out of the amazing discovery we found in that, not just about the evolution, but the fact that they're the only vertebrate venom that acts on sodium channels, and they act on a type of channel that's involved in the broad channel type is involved in a myriad of things ranging from pain to muscular dystrophy. And in the particular one that we looked at is actually hitting selectively on the same type of channel that's involved in myotonic muscular dystrophy. So it's obviously something of massive importance from evolutionary theory, but more immediately applicable as an investigational ligand for a tremendously important human disease. So it's a new form of irony to have that find out that that application got knocked back on the same day that literally the news went viral. It made global news. It's been translated into countless languages. If you type in long-glanded coral snake and my name, you'll literally get hundreds of thousands of hits. So that really took the wind out of our sails. But it's, of course, not just my own little pity party here. It's an example of the broader problems with science funding right now, that even the stuff that's getting high-profile press still isn't getting funded. And that shows that the system is fundamentally broken at this point, where it's such a capricious lottery that the funding rates are around 10% in the US, UK, and Australia as far as success rate for the major national competitive grants. And this is crippling our future because science is the backbone of any economic endeavor. And we need to fund the blue sky projects because we can never predict where that great bit of serendipity is going to occur. But when even very acutely focused applied projects are still getting knocked back, then that means that we have big, big issues on the very fundamental level at the moment.
Certainly, it can be very disheartening. And I think hearing you talk about these challenges, these problems, you can sense your passion for the research, how important it is, not only for you, but things that you can foresee having a big impact on the world. And I'm curious to hear a little bit more about, Bryan, where this passion started. Can you tell us a little bit about some of the people who might have inspired you or encouraged you along your own journey?
Well, all my life, I've been fascinated with the natural world of toxins and snakes in particular. My first memory is actually being 2 years old and strapped to a hospital bed with my head, arms, and legs restrained because I had spinal meningitis and I was in absolute agony. I can actually remember this. And the reason they had me restrained is that I kept pulling the tubes out, even the ones that they had inserted in my temples. And I was one very, very sick little baby. I'd picked up spinal meningitis at a daycare in Washington, D.C. on the military base there. Luckily, of course, that with the Walter Reed Hospital there's some of the best medical care in the world. So I survived. It left me deaf in my right ear and with shocking balance, which is where some of my injuries have come from, as far as falling at the wrong time and just happened to be at the edge of a cliff. So like I could fall all the time. Like if you put me in a room and turn the lights off, I'll walk 3 steps and then hit the ground.
Oh, wow.
So this gave me a very early awareness of the concept of mortality, but also the idea that there's these invisible forces that act on you, and then the rest of your life is on a completely different trajectory. And then I'd be looking at my mom's photo albums of her growing up, where she was the daughter of Norwegian diplomats who worked all over the world, included living in Africa. So I'd look at pictures of they had cobras in their garden. They had a gaboon viper in their tennis court. They once had a black mamba come into their house. They had a 7-meter python come into their house one time. I got just fascinated with these animals. And my dad was in the American military at the time, so we were living all over the place and bouncing around the globe on different military bases. And everywhere we went, I would try to find the local creepy crawlies, and just allowed me, that early formative experience really shaped the rest of my life. It's like that classic saying of, give me the boy until he's 7 and I'll give you the man. Well, this boy up until he was 7 was a flower piglet happily playing in all the mud puddles, and that's pretty much the man today.
Some things never change, right?
Well, yeah, like I just got home late last night from a particularly interesting trip where we were out looking for inland taipans out in Windora, and this is the world's most venomous snake. We didn't see any because the trip ended up actually getting cut a bit short, because my best mate Chris actually got bit by a venomous snake while we were out there collecting, and we had to do a 5.5-hour emergency drive across the deep desert to get to the nearest hospital. But we couldn't speed. It's middle of the night. We still had to do only 80, 90 kilometers an hour, about 50 miles an hour, because there were so many kangaroos on the road. And it's a very narrow, twisting road that obviously we hit one of these and end up in a gully. The paramedics who eventually make it there, if we ever get found, aren't going to be thinking snake bite, meaning more mundane injuries. And Chris went into allergic shock while we were driving, so I had to give him adrenaline and antihistamines in order to counteract the shock. The pain radiated up his arm. By the time it got into his shoulder and then into the rest of his body, we still had 2.5 hours left to go on the drive. And by the time we got him to the hospital, he was gray and looked 100 years old. It was not his first snake bite, not the first snake bite that I've been involved in that didn't involve me, but it was easily, I would say, the scariest snake bite that I've been in, just because the distances and the time factors were so profound.
Certainly. So I guess my first question is he going to be okay?
Yeah, we got him to the hospital in time. We had a brief moment of phone reception. We managed to get a hold of the hospital to let them know that we were on our way. Here's what bit him. Here's what antivenom they need. They, of course, did consults with the poison control while we were still in transit to confirm everything that we had said, as far as what kind of symptoms. And they were ready and waiting, and we got the antivenom into him very, very quickly. And you did a very quick turnaround as far as the reversal of the effects. So it all came good, but it was deeply distressing to have, almost have your best mate literally die in your arms. So I'm a little drained today. I'm planning on just having a very quiet day, a little short walk in the woods with my wife and 2 darling little staffies, which are little minion creatures, which are so ridiculous and clueless that they always make me feel better.
Yep. Dogs have that effect on me too. So now you mentioned that you had this traumatic incident as a child that maybe sparked your interest in science. Did you ever consider medicine?
I did actually for a while, but being a snakebite treating doctor, that many doctors, even in Australia, will go their entire career without treating snake bites. And I really had no interest in treating ordinary pedestrian injuries, broken bones, cut, suturing up, things like that. Of course, naturally tremendously important and vital services just weren't my cup of tea. For me, it was all about venom. So I'd rather spend my time learning more about these creatures that I find so fascinating.
Certainly. Was there ever a time, you mentioned some of these really scary incidents, where you considered changing your research direction? Was there anything that ever turned you off from this field?
Yeah, there was one time where I seriously thought about taking up another career. And that was a time that I got bit by a type of snake during my PhD called a Stevens banded snake. And what it does is it absolutely nukes the ability of your blood to clot. And one of the first effects that showed up was I started bleeding out of my eyes, which I actually thought was really cool. It was like terrifying in a really awesome way. It looked like stigmata. And I wish I had a photo of it. It was the most metal thing I've ever seen in my life. But when you are bleeding out of your butt, by definition, life is not cool. So I'm absolutely terrified at this point, because that meant that I'm systemically unable to clot. And I was deeply afraid of bleeding into my brain. And if I survived, ending up a vegetable or, of course, being killed outright. So that cold grip of terror and that particular bite really did make me think that maybe working on butterflies might be a better...
Something cute and fuzzy, maybe.
But once I recovered, the bravado came and yeah, we're back at it.
Gotcha. So can you tell us, what are some of the things that took you from this point of being an early scientist interested in venom to where you are today? Were there other turning points along your career?
Well, one was when we were living in Florida when I was in first and second grade, and we lived just a couple blocks from the Miami Serpentarium, which was run by Bill Haast. And I used to love going there and watching him milking the huge king cobras that they had. And it just really solidified, that this is what I want to do. When I was 4, I'd already grandly announced that I was going to make venomous animals my life work. But unlike, little Jimmy, you declared you wanted to be a fireman, here I am, 45 years of age and professor at the university doing my childhood dream. And I reckon the world would be a much weirder, but a much nicer place if more people followed their childhood dreams.
I don't know. I think I'm lucky that I didn't follow mine. I'd be like a magician dancer or something like that. So I don't think I'd be making much money that way. Well, fantastic to hear a little bit more about your path. And I know, Bryan, you did travel to Australia then to get your PhD. Can you tell us a little bit about what that experience was like?
Yeah, I was 16 and I decided that I wanted to move permanently to Australia. So that was my goal, that I always wanted to do my PhD in Australia. And getting the international scholarships are brutally competitive. Like the year that I applied, there was 12 on offer and there was over 300 applicants for those two. But I had prepared for it, where I was just obsessive in my studying as an undergrad. I remember that I was so annoyed whenever I wouldn't get a perfect 4.0 by missing out by having an A- and having just a disgraceful 3.9 out of 4 for my grade average. These kinds of things just drove me to no end. And I was the annoying person in class who would go up and argue for points after an exam despite getting the high score, because I was so driven to get that scholarship. And I knew how hard they were, that I had no social life as an undergrad because I was doing a double major with a minor, but it was all worthwhile. But any good goal is worthwhile. Then made up for the lost time during my PhD as far as the socializing. But it was a very, very arduous, grueling ordeal to get that PhD scholarship. But of course, it's anything that's hard to get is worth doing.
Certainly. And you returned back to the University of Queensland, so you must have loved it there. Can you tell us what it was like coming back as a faculty member and a fellow?
Oh, amazing. So I'd spent 8 years in the land of cold and rain down in Melbourne, which is sort of the weather equivalent of Portland or Seattle, where the sun never shines, that low gray hanging sky and that aggressive sort of dampness. Not my cup of tea. I'm very much powered by sunlight. I'm one of those people who gets crippling seasonal affect disorder if I don't get enough sunlight. So Brisbane for me is the perfect climate because it's a subtropical climate, much like Florida. So the wet season is in the summer. The laughably named winter is the dry season, where it's 70 degrees and blue sky day in, day out. But more importantly, UQ is an absolute powerhouse globally for venom research. We have an unusual concentration of people there working on venom. Most of them are working on cone snails because they're very, very much the flavor of the month for development of new painkillers. But there's other people working on assassin bugs, scorpions, spiders, jellyfish. So it's a very dynamic environment and unusual intellectual melting pot as a result. And that, of course, is how science should work. That's where you get that emergent property of 1 + 1 = 3.
Certainly. And I know there's also research going on there on things like lorises, platypus, and shrew. I didn't even realize these things were venomous.
Yeah, so in my lab, we don't just work on snakes. We work on snakes, spiders, scorpions, jellyfish, slow lorises, which are the only venomous primate out there. We're working on venomous shrews. We're working on the solenodon from Cuba. We're working on a myriad of different animals, including we're the ones who discovered that Komodo dragons are actually venomous, and everything you've heard about bacteria is wrong, through to working on venomous octopuses that I collected down in Antarctica, some of which we've gotten nets nearly 2K down under the surface.
That is phenomenal. So, Bryan, I'm going to make you pick one today. Can you pick one project that's ongoing right now that you are so excited about that you want to give us a little bit of detail on?
I'd say it would be the long-glanded coral snake project, where this is a snake that has the longest venom glands in the world. where they can extend between a quarter and a third of the length of the body. Now, why, of course, does it need such ridiculous venom yields? That's what we set out to discover. And how is this venom acting? These snakes are a killer's killers, the best way to describe them, that they're a specialist for other venomous snakes who in turn specialize on other snakes. So they eat young king cobras and krites, so extremely dangerous prey items, who obviously have a very high potential for prey retaliation. And this has led to an unusual selection pressure. And what's happened is that it's ended up as a remarkable case of functional convergence, where the venom of the long-glanded coral snake are the only vertebrate venoms, let alone the only snake venom, that acts on sodium channels, where what they do is they, in effect, imagine that they pin the gas pedal to the floor, opening up these channels and causing all the muscles to spasm, and then they cut the brake line. So they prevent the channel from deactivating. And this causes a rigid, spastic kind of paralysis that's very, very fast acting, but it's not as potent of an action as your normal sort of sedative type neurological reaction that you get from more conventional neurotoxic snakes like cobras, for example, where people and the animals die of a limp paralysis and where they suffocate because they can't inflate the lungs because the diaphragm is paralyzed, but paralyzed in an open state, where in the paralyzed in the relaxed state. In this case, it's paralyzing in the contracted state, but because it's not as potent, that's in turn been the selection pressure for the evolution of these very long glands. Now, what's interesting is that it's hitting the same intersection as you have for animals like scorpions that are feeding on flying prey that land and they sting, or cone snails that are feeding on fish that obviously it's a snail that can't swim. So if that fish gets anywhere in the water column, it ceases to exist. It might have as well disappeared through a wormhole into an alternate dimension. Mm-hmm. It is gone from the perspective of the cone snail. Now, cone snails and scorpions both cause this extreme sort of paralysis, of this spastic immediate paralysis. If you go to YouTube and Google cone snail, you'll get any number of videos of them feeding, and you can see that's like this lightning strike of electricity where their fish become literally instantly paralyzed in this spastic sort of way. And that's driven because of extreme prey escape. But with the long-glanded coral snake, we've shown that we've ended up at the same functional point because of an extreme chance of prey retaliation. But in each case, the same evolutionary, quote-unquote, good trick has resulted. So that's the part of science that I find so fascinating, is when you get these areas of convergence, and then you can start examining sort of what historical contingency led to these kinds of fascinating parallel universes.
Certainly, that's really interesting. So are these long-glanded coral snakes unique to Australia, or can they be found elsewhere?
They're actually found only in Southeast Asia.
Ah, gotcha.
So these are from field work that we've done and from work that started when I was living in Singapore and working there. So it's been a very long-term project we finally just cracked the riddle of, and we're absolutely thrilled. And it's one that we're intensively diving into now for follow-up, particularly because with this site of action for some of the toxins that we've pulled out of the long-glanded are acting specifically on very narrowly defined subtypes of sodium channels. And in particular, the action is almost exclusive on NAV 1.4 type sodium channel. And the reason that this is important from a human medical perspective is that this is the channel that's involved in myotonic muscular dystrophy, where in the disease state, it's the exact same mechanism of action where people have a mutation in this channel that causes it to turn on too easy and is more difficult to turn off. And these people end up with spastic paralysis, which is debilitating enough in its own right. But the reason it ends up in muscular dystrophy, which is destruction of the muscle, is that imagine that you're continually flexing your bicep all the time, flexing it harder than you can yourself. Obviously, you're going to end up with micro tears, and you're going to end up with a chronic cumulative muscular damage. And this is the kind of thing that we think it is tremendously important for this venom, because we can use it as a selective probe where we can recreate this disease state with a strip of muscle in the lab and study the physical effects that are occurring. But yet again, this is also a nice illustration of our frustration, where we got that grant application knocked back, which just left us as very, like I said, took a lot of wind out of the sail, that we think that we're onto something here, but convincing the powers that be, even when we have the first really massively pinpointed applied project. We're still struggling to get funding. And it's not because it's unfundable. It's more that the pie is so small right now and the slices are so thin that of the 10% of people who are getting funding, of their 90%, I would say estimate over half of those in a typical year would get funded. But the funding pool is so shallow now that I think that they should just make it a lottery. This assess, is this something fundable? And then just spin the wheel, because that's as capricious as the current situation is anyway.
Right. I think it highly depends on who's actually reviewing the applications, what sort of review you're going to get. So,
yeah, there's always that old boys network anywhere on the globe. And certainly, that's no different here in Australia than anywhere else.
Certainly. So I think you brought up some important challenges in our discussion so far, Bryan, but I love talking about some of the challenges and struggles and failures that scientists have, because I think a lot of times these stories don't see the light of day. You only hear the success stories that come after years of struggle. So is there a story that you can share with us today that highlights one of your failures or struggles and how you got through it?
Well, right now we're actually in our biggest struggle where we've run out of money because we went 0 for 6 for grants, despite spending 4 months writing grants last year. So we were on absolute vapors for next year. And it's so deeply ironic because we're making our biggest breakthroughs. We got an equipment grant earlier this year to set up this insane blood testing array, where we even have the Rolls-Royce of blood coagulation analyzers, the StarMax made by Stego. And this is the ultimate machine where there's not a single hospital anywhere in the globe, even the best hospitals in the US, wouldn't have anything better than this. It is the primo machine. We got only the 6th one ever to be imported into Australia, the first one ever in Queensland, and the only one in a research lab. So we have this ability to do 200 samples an hour, for example, of coag testing. So I know that the long-term future of the lab is completely secure. We just need to survive this acute walk through the desert of the short term. And it's a very strange feeling because normally it's the short term that is taken care of. It's the long term you have to fret about. Luckily, the School of Biological Sciences is being supportive, and they've given us a little bit of departmental money to help us keep the lights on, because obviously it's in their best interest that we don't fail. But it's just a little disheartening for not just for me, but also my students. The 8 research students that I have are looking at this and thinking, well, wow, if a lab like this that's pumping out so many high-profile papers a year is struggling, what chance do they as young scientists have? And that's a real problem, is that it's sucking the motivation to live of the junior scientists. They're thinking, well, maybe I should just become a vet. Maybe I should just become a doctor. People and animals are always going to get sick. I'll always have a job. But that means that we may miss out on the person who could have made the next cancer discovery or discovered the next penicillin, because they're just treating colds and flus and not using that magnificent brain to make those kind of society-changing discoveries. So it's not that I'm having a big pity party about my own predicament. It's more using that as a symptom of the much more fundamental problem that's going on. And if you look at the people who are leaving science in droves right now, even some very senior people are leaving, that this is the kind of thing that is going to have long-term society impacts.
Certainly. And I know you are absolutely not alone facing these short-term gaps in funding. I think bridge funding sources popping up from within universities to try and help address this problem. But you're absolutely right. It is almost an epidemic these days. And I'm curious, what do you tell your students who are maybe starting to lose their enthusiasm and starting to worry about their own futures?
Well, saying never give up, never surrender, of course, can ring a little hollow after a while. All I can do is set by example. And that's why this last trip was so ironic, because I had finally reached the end of my tether and just said to my students abruptly last Monday that that's it, I'm done. I need a holiday. I'll be back in a week. I need some time and space just to get perspective. And this was supposed to be a relaxing little holiday out looking at inland taipans, which is what I would like to do for fun. It wasn't supposed to be a mad emergency dash across the desert with my dying best mate in my arms. But the irony is that it has given me perspective, that near-death experiences make you value that, well, here's what I have. So my focus is switched back to not from what I don't have, but over to what I do have. I have an amazing lab. I have brilliant young students. I've got enough funding to survive long enough to hopefully secure some funding. So it's put my focus back onto it's not the end of the world. We will survive, as that very famous saying, this too shall pass. That's all I can do, is just lead by example and then just keep trying to convince them that if you keep achieving, things will take care of themselves in the fullness of time. But they need to be able to see that happening around them in order for them to believe it themselves, because they need a little bit of external validation so that they know that the light at the end of the tunnel is not a train.
Right.
So what we're doing is we're doing a lot of our own efforts for bridge funding. So we have a crowdfunding site for cures for corals. So if you go to crowdscience.com or just type in cures from corals, you'll see what we're doing there. Because we chose what we thought was our most high profile project, where, of course, the Great Barrier Reef dying from climate change is global news now. And we have some samples from areas that have now actually been wiped out by the bleaching. And you won't ever see these samples again. Those 1,000-year bombies are dead. That we know that corals and sponges have already led to a number of medications in pain and cancer treatment. So we want to continue that, where we already have 2,000 purified molecules. We have crude extracts from another 200 species, which represents another 50 to 100,000 pure molecules. But with that 2,000, we're at that sort of nearly there kind of area, which is the most compelling argument for funding, that with $20, we can test one sample through a complete battery of assays, including the blood treatment side of things, which has never been really investigated for these kinds of very powerful chemicals that we know are in them, that we may find a new stroke treatment. Because the reason that corals and sponges are such well springs of these novel compounds is that it's a chemical reef. They are fighting amongst each other, but they're using chemical weapons instead of mechanical weapons, because, of course, they're sessile and mobile animals. But like if you take, for example, some of these sponges, put them on a rope, submerge the rope for 2 months, and then bring it up, there'll be algae covering the entire rope, meter-long strands of it, except for where that piece of sponge is, a meter in either direction. The rope is pristine because those chemicals are killing all of that other growth. And that means that these are the kinds of things that are great for cancer treatments, for example. So we know that they're potentially useful in a very immediate way. And so that's why of the myriad of projects we have going in the lab, we felt that that was the one that was the most PR friendly and the most crowdsourcing friendly. Because if you look around on Facebook or anything like that, you'll see just request after request after request of crowdfunding, where there's this tsunami of crowdfunding out there. And yes, crowdfunding does work. You can scrape a little bit of money, but it's not that people are flocking to it because it is the golden goose, but rather just out of sheer desperation that the conventional sources are being hammered. I mean, what do you think is going to happen to ecological funding research for the National Science Foundation in the US with the Trump presidency takes on? Nothing is going to happen, because they're not going to want to fund it, because they want to open the national parks to strip for fossil fuels or minerals. And the last thing they want is people pointing out inconvenient truths regarding cyanide leaching and things like that.
Sure. And I think you brought up some really good strategies in terms of diversifying your funding sources and ways to try and combat this and just struggle through until you get the next big grant. And I think that is so important, not to lose that fighting spirit, to never give up, never surrender. But I don't just want to focus on your challenges and struggles. I think there are so many in science, but I love taking a moment to celebrate the successes, because I think it's so important to take a pause, reflect on these successes, because oftentimes that's what keeps you going. So do you have a success story, Bryan, that you can share with us today, whether it's a big one or even just a small one that meant a lot?
It's coming back to the long-glanded coral, just because it's my favorite snake. If you look at a picture of this animal, so if you type in long-glanded blue coral snake, you'll see a photo of this amazing creature with this just neon red head and tail and these electric blue stripes running down a black body. It looks fake. It's so vibrant and so outlandishly colored that from a simple aesthetic perspective, it's just absolutely gorgeous. It's a living piece of art. And then when you throw in these freaky long venom glands, the epitome of venom diversification, and these toxins that act more like a scorpion or a cone snail than it does, anything we've ever seen from any other kind of snake. And then the evolutionary history of that, they're feeding on king cobras and things like that, that it just, all of that combines to where the forever 8-year-old in me is just looking at this thing, just head happily resting on the hand, little line of drool running out of the mouth, and just a big stupid grin on the face looking at it.
I like it. So that's fantastic. So can you remember what was going through your mind when you had the success, when the pieces starting fitting together on what's going on with this sodium channel?
Well, panic, because it's amazing how often where you, by virtue of discovering something phenomenal, you seem to pull it out of the universe and where other people make the same discovery. It's incredible how often different research labs come up with the same thing. Like with the HIV AIDS link, for example, a French and the US lab independently came up with that, and they ended up publishing the same issue of Nature. That was our thing. It was like, oh my God, we're going to get scooped. And in fact, there was a Malaysian group who were working on it, who published before us on just the basic venom composition, but there was nothing really exciting in there in that from a superficial look at the type of classes of toxins that are in there, there's nothing extraordinary, but they didn't have our technology to be able to look at the function, and that one of these toxins that is it's the same toxin type that would normally be causing the limp, sedated kind of paralysis. Instead, as the neurological action, the polarity of that has effectively been flipped. And now instead of deactivating, it's activating. But if you just looked at it as far as just a basic venom profile, you can't see function. So when that paper came out, and when I first saw the title that they're working on that, I'm like, oh no, oh no, oh no, oh no.
It's over. Yeah.
Then I read it, I'm like, oh, woof, they didn't have the ability to test that we did. And then we still had a little bit of work to do. Near enough is not good enough. We had to finish things to a certain standard. And we, of course, could not rest until it actually came out. And only then did we allow the feeling to rush through us. And elation was not our first feeling. Our first feeling was one of just exhausted relief that we didn't get scooped. Because that's, of course, your deepest fear, because there can only be one as far as being first.
Right.
After that is me too. And of course, the prizes go to those who are first. That would have been years of work down the drain and extraordinarily dangerous work as well when we went out to collect these things. That yet not only were we in the middle of nowhere as usual, but with a snake that I only knew of 3 bites from, and 2 of them died. And it was touch and go for the third person. Because it's such an unusual animal, there's no treatment for it. That even if we had reached a hospital, all that meant is that we died in a nice, clean place.
Gotcha. Well, congratulations on this success. And I love that you bring up your almost childlike curiosity and admiration for this long-glanded coral snake. So, Bryan, thank you so much for sharing the story. And I know in the beginning of our introduction, I mentioned that you were the author of 2 books, one a textbook and one a book that you had written, a sort of a memoir. Can you tell us a little bit about what you like to read in your free time? Do you have a favorite book that you can recommend to me and our listeners?
I like reading really broadly. So I read ranging from stories of adventurers. So like when I was inducted into the Explorers Club last year, that was a childhood dream come true because my mom's Norwegian. So we'd spend our summers back in Norway looking at the Viking ships, just wanted to be a Viking and going across the ocean, discovering new lands. And then a more modern day Viking of Thor Heyerdahl, who did the Voyage of the Kon-Tiki, which was actually made into a not bad movie relatively recently. But the book itself, his journal from that and the footage that they obtained while they were doing that, just really set that into me of that I want to be this kind of explorer. Then I saw that he was inducted into the Explorers Club. What's that?
Yeah, must be in that.
So reading those kinds of books of or the Shackleton expedition down south, those sorts of things really get me of where it's seeing what people did to get through the side of the mountain, because it's not the top of the mountain that's the important part. It's the side of the mountain. You can take a helicopter to the top of any mountain, but can you get there on your own power? That's where the testament to the inner spirit really comes through, and your ability to grind. So I've always really enjoyed reading autobiographies and biographies and books about people who had a goal and how they persevered through the darkest of times and a massive accumulation of scar tissue along the way to get there. And that's, of course, what you go through to get there is what, of course, gives it the intrinsic value.
Definitely. It's those things that make it the most memorable. And I know you have had so many phenomenal adventures on these different travel opportunities for science, whether it's field work. I know you've been to a lot of different places for your work. Is there one place that sticks out in your mind, Bryan, that was just the most memorable or your favorite place that you've been for your science?
Plenty of memorable. To start with favorite, that would be Antarctica. It is literally as close to a religious experience as I'm ever going to come, being, of course, an atheist. But it was just so beautiful, so pristine, just made me want to weep at just the beauty of it. It and why we need to protect such wild places. But that's one of the things that drives me is I want to see these kinds of places while they're, of course, still there to be seen. Some of my favorite dive spots where I've had some of the best times of my life on the Barrier Reef are now just a white graveyard with the destructive bleaching from the corals being overheated by water temperatures. And then there's other sides of the memorable parts of it where there's 2 countries my wife has forbidden me to go back to, and that's Colombia and Pakistan, because we got kidnapped in Colombia and they let me and my mates go pretty quickly because they saw that we had bags full of venomous snakes because we just started showing them the snakes.
Oh my goodness.
Guys doing here? And they thought it was cool and let us go. Maybe the FARC people were snake catchers in their spare time. And then in Pakistan, we were deep in the Sindh desert and we started getting graffiti on the sides of our building with flags with swords going through them and some squiggles off to the side that didn't need to know what the squiggle said in order to know exactly what message was being sent, which is leave. And we had similar sorts of incidents in Karachi. And 3 days after we left, the first big wave of suicide bombings that ever hit Karachi hit there. And these weren't individual vests. These were cars full of bombs. And our building that we were staying in, our safe house, was one of those that was blown up.
That is incredible. So have you ever decided perhaps not to take a trip that you were wanting to take for your research purposes because you didn't feel safe going somewhere?
No. Probably should have.
Maybe someone with better judgment would change their mind. No, I'm just kidding.
Yeah, well, like this last trip, it's one of those ones where it was just a cursed trip, and Chris's mom had just one of those feelings we shouldn't go, and my wife wasn't too thrilled about this one. And of course, I always listen to the mothers and the wives of the world because, they have this ability to sense things, perhaps. But yeah, it's just one of these ones where we come back with Chris with a snake bite and me with new additional stitches in my hand I cut myself really badly, ironically, the same morning before Chris was bitten. So we started the morning off with me gushing blood and Chris applying bandages on me using duct tape, of course, because ordinary white tape just won't hold.
Of course.
And finished the day with me bandaging a bleeding Chris up, also using bandages with duct tape. We have an unusual friendship.
You cannot travel without duct tape. This is a must-have, right?
Exactly. Does it move? Yes. Should it? No. All right. Apply duct tape. Does it move? No. Should it? Yes. Okay. Apply WD-40. Between duct tape and WD-40, you can do just about any repair.
And now I know you've had quite a record of injuries on these different trips. I think 400 stitches I saw, 27 snake bites. What keeps you going out in the field despite these injuries and crazy things that are happening?
A lot of modern science goes into keeping me going, where I've had a lot of permanent effects, both physical and also chemical. So starting with the physical, I've broken my back twice. The first time was the one that really mattered. The second one was just a fracture on the right process of L3. So that was just 2 months in a brace. That was no big deal. But the first time I was in hospital for 4 months, broke it in 3 places, and I ended up actually repairing the vertebra. And I was partially paralyzed. They did the surgery, decompressed the nerves, and my legs started working again. But to repair the vertebra, they put cobalt metal end caps onto 3 of the vertebrae with artificial discs in between. So I have this spine that's like Wolverine. Mm-hmm. And whenever I go through like a scanner at the airport or get an x-ray at the hospital for unrelated things, there's always a conversation of exactly what is going on with your back. So I've broken 24 bones so far. I've just added a few more stitches to my tally. It's somewhere in the mid 400s by this point. 3 concussions, 27 snake bites, 3 stingray stings, 1 scorpion that almost killed me in the Amazon. But the irony is that what actually has left the most interesting permanent effect has actually been from when I was in the hospital for the broken back. And so for 4 months, I was getting intravenous long-term acting opioids like hydromorphone. Well, it turns out that a mate of mine who's an ER physician said, have them check your hormone levels afterwards, because he sees it a lot with car accident victims with that kind of shock to the system and then the hormone being suppressed actually by the opioid. So whenever you take any kind of opioid, whether a short-acting one like Vicodin through to long-acting ones like hydromorphone, in males, I don't know what happens in the females. I've only researched on the male side, but in males, it suppresses testosterone and nerve growth hormone down to nothing, or at least some suppression, but in some cases all the way down to nothing. And then it'll bounce back to variable degrees depending on what you've taken and how long. So like with hydromorphone, long-acting ones, it bounces back slower or if at all. So in my case, mine didn't bounce back. I flattened all of my hormones. And now because of that, I need to daily inject myself with nerve growth hormone. So human growth hormone, a daily injection of that. And also testosterone. I have to take DHEA. I have to take 8 different things each day. to replenish my hormones. And it was an interesting one psychologically, because first off, when they were trying to get the balance right, there'd be times where I'd be hyper-androgenized, and being over-hormoned was some of the most intense shit I've ever gone through in my life.
Oh, geez.
Psychologically, I'd be out on my motorcycle as just an absolute madman. But then also it goes to the psychological implications of what does it mean to be a male? Am I less of a male now because of that? And it was interesting, but that didn't bother me so much because I knew it could be fixed with replacements. But it allowed me to start investigating this. And it's something I'm actually writing a popular science book as sort of to help bring this into broader awareness. Because how many times have you heard people who've been in a major accident and took a lot of painkillers for a long time and they say, yeah, I've just never been quite the same? Well, that's not the injury. It's actually the hormones. And it's a silent epidemic that male hormones don't get the attention that female hormones do, because, of course, females go through an acute form of menopause. So a hormone disruption, and then they do hormone replacements. This is very well established. It's very scientifically validated. But males, as they age, naturally lose and decrease testosterone. But that leads to jokes of like, oh, well, what's the difference between male menopause versus female menopause? Females get hot flashes and gain weight. Males buy a sports car and date younger women. So that kind of joke superficially is funny, but it trivializes the issue on the male side, where from natural hormone age-related changing is actually, I think, a very valid scientific phenomenon that needs to be addressed. Because if male hormones drop down too low, it actually ironically becomes a major factor in the development of prostate cancer, for example, and also for some reason diabetes, for a link that hasn't been made, but it is established that the link is there, but the pathway remains enigmatic. But the more acute things, like what happened to me with the hormones, also happens with other things, such as statins, for example. The anti-cholesterol drugs are very important and very medically needed. But if you reduce the cholesterol too much, the cholesterol is actually the starting substrate for the biosynthesis of hormones like testosterone. Antidepressants, many antidepressants actually shut down male hormones. And so like the joke of, oh, if you take antidepressants, it's because you're a big girl. Well, no, it's going to turn you into a big girl chemically, through to even some antifungals. So I've been going through all the literature and going through PubMed and pulling all the scientific articles and documenting this very carefully. Some plastics, your typical takeaway container, the type of plastic used in that is a very cheap plastic. Well, it leaches out, and a lot of those are actually estrogen mimics. So from a male hormone perspective, it's as if you're taking estrogen cream. And that has actually already been documented as a huge link to the global shift in male fertility, where male infertility is dramatically on the rise. And pollutants such as takeaway container plastics and those estrogen mimics are one of the ones that's a big, big issue. So there's a myriad of these sorts of things that just aren't talked about. So I'm writing it, it's called Mojo Mayhem, Male Hormones and the Chemicals That Hate Them is the working title. But I'm working with my endocrinologist. And so for each of these kinds of scenarios, I have to see a specialist once a month to get my hormones checked and the meds dialed in a little bit tighter as things vary. But for each of these sorts of things, he's got at least one clinical representative case that we include to show that it is a real world scenario, that this is not just some sort of woo-woo, this is actual science. But I think that it is very much a silent epidemic. And that was actually the linchpin for my idea of writing the memoir Venom Doc, because I'd long thought about doing it, but you can only have so much balls to the wall, type A, irresponsible behavior before it becomes a little farcical. So the storyline trajectory of the book has a natural one because it's my life. It has a natural, very realistic one, but it has a story arc where I end up like Icarus, flying too close to the sun with all these extreme adventures, some of which were probably incredibly ill-advised. But then I come crashing down to earth with a broken back. I think that I'm fine, but I'm not, because the hormones part. So that's the chapter. This is Spinal Tap is the title of the chapter. I wanted to use that to spark the broader conversation regarding male hormones and how important of a consideration this really should be. But men never talk about their own sexual health. It's forbidden. You're not out there fishing with your mates, impaling a worm on a hook and saying, hey, how's your prostate?
Right.
It doesn't happen. The only time it happens is you're at a funeral and someone says, yeah, he died of nut cancer. But if you look at like all the run for breasts and all the breast cancer awareness campaigns, great. Now, women are much smarter, which is why they live longer. but they talk about these things. They don't have the stigma or the inherent insecurity, because it is the insecurity of that if there's something going wrong in that area, you're perceived by yourself, even though it's unrealistic, but you consider yourself less of a man. So you don't see run for prostates. Men aren't out there advocating for their own sexual health. And it's reached the point that, like in Australia, at least for the prostate awareness campaigns, they've actually switched the focus to the women, to getting them to nag their boyfriends or partners or husbands to go and get checked, because just getting men isn't doing it, even though more men actually die of prostate cancer each year than women die of breast cancer. Yet the social awareness of this is a lot less, because men are being insecure little boys and not talking about their own sexual health.
Certainly. Well, I'm really glad you brought this up, and we'll have to keep an eye out for your upcoming book, Mojo Mayhem. I like the title there. And I think throughout our conversation, Bryan, we've talked about a lot of experiences that you've had in your life that are perhaps contrary to the stereotype that people may have about what life as a scientist is like. And I love talking about these stories because I think it's important to share all of the different things that scientists do as part of their career. You're not always just sitting quietly in a lab by yourself. You're working with people, you're going out in the field, you're doing exciting, interesting things, and you're working with exciting, interesting people. So do you have a story that you can share with us today of maybe the human side of science, one of these quirky things that has happened on one of your trips, or some of the fun people you've been able to work with?
Where do you even begin on that one?
Yeah.
One that really was interesting was when I was in Pakistan, I gave a lecture at the University of Karachi, and the previous military strongman who had been in power, Sharif, had one of his best mates was Khan. Well, the one, if you type in Khan nuclear weapon in Pakistan, you'll get a lot of hits on this one. So they were funding the nuclear program surreptitiously by putting a lot of money into general science. And as a result, for a period of time there, Pakistan science was actually extraordinarily well funded. And it, even to the point to where they had video hookups all over the country, where they had their own sort of intranet for the country, where anybody could actually dial in and watch one of these scientific talks that was being given on at any of the universities. So I'm giving a lecture there, and they said, oh yeah, we have a hookup to people across Pakistan. I'm like, oh, that's interesting. I'm thinking some people Skyping in, but it meant that people outside the universities could actually click in. So, and we could see them on a big screen. And one of them that came on was like your stereotypical Hollywood terrorist villain, the thing around the head, the scraggly beard, the squinty eyes and all that. But then he was actually incredibly nice. And he said, oh, just loved your talk. Don't really have any questions. I just wanted to tell you how long I've really enjoyed following your work, and I love your webpage. And my jaw just hit the ground. It was one of those rare and wonderful occasions where I was actually at a complete loss for words.
Well, I think it's wonderful to break some of these stereotypes, not only about scientists, but cross-culturally. And I think that's one of the great things about having an opportunity to travel to different places and to talk to different people as a scientist.
It's important you actually just mention that, because that scientists should be immune or excluded from your view of the politics of the country. And that's why, I don't know about it in the US, but it keeps flaring up in Australia, where we keep having people putting political pressure to disinvite Jewish scientists from attending conferences here, or break funding for scientific collaborations because of how the Jews are treating the Palestinians. And of course, that entire area is a historical mess going back thousands of years. We're just seeing a modern day version of a long time culture war where atrocities have been committed on both sides, and neither side is right by any stretch of the imagination. But to politicize science and to make the scientists as if they're some sort of representative of their government is, I think, wrong on every conceivable level, because when you have scientists meeting and scientific exchanging happen, this is where it breaks down exactly those kind of cultural barriers and stereotypes to reinforce that people are just people.
Absolutely. And I think that is one of the things that I find most valuable when I'm going to scientific meetings is talking to people from all over the country, hearing about what it's like to do science in their country, and also finding there's actually a lot of common ground.
Indeed.
So fantastic to hear about one of these quirky stories that happened to you when you were giving a talk at a conference. And I'm curious now to hear about some of the things that you've been researching, some of these big questions that have been in your mind. And we've mentioned that funding is often a challenge in science. But I want you to dream big with me today, Bryan. If I gave you everything you wanted, funding, staff, technology, feasibility, sky is the limit here. What is the one question in science that you are still dying to know the answer to?
Well, ironically, I wouldn't actually go for a question. I'd go for something that we already have the answer for, but that there's not the political will. And that's to develop antivenoms for regions that don't have it, because snakebite is the number one neglected tropical disease where everyone goes on, oh, Australia's full of dangerous animals. Yeah, come on, get a life. Yes, we have some venomous snakes here. Yes, we have a few spiders that'll tear you apart, but more people die in the shower each month than die every year in Australia. Only 4 to 6 people die each year in Australia because there's not a lot of bites. There's only a few hundred bites a year. We have amazing antivenoms, but our antivenoms cost about the average of 1 billion times the daily wage of somewhere else in the world that could really use their own type of antivenom. To put it in perspective, more people die every day in India every 5 minutes from snakebite than die in the entire year in Australia, where India has about 1 million people a year being bitten by snakes. Of those, about 50,000 of them are dying. Now, that's only a 5% death rate. That's probably underreported. It might be 10 or 15%. But of the survivors, over half of those are having some sort of permanent injury, whether it be loss of a limb, destroyed kidneys. Now, the people who are being bitten are typically the breadwinner out there doing farming. Well, now it's not just them, but their entire family who are suffering economic death. So that's the illustration of the real social impact, the socioeconomic cascade that happens with snakebite. And it's no different in Northern Africa, Central Africa, where the people who need it the most can afford it the least. And companies aren't going to make it. Like Institut Pasteur has just stopped making their last antivenom for Africa. So now Northern Africa is antivenomless. And we're back to the bad old days in that regard. So it's one of these ones where they can't afford to make their own. The WHO has other problems like malaria and AIDS, and they have a fairly scarce budget. Gates Foundation isn't really interested in it. They're going for the high profile things like malaria and AIDS yet again. So it is the number one neglected tropical disease because these are orphan drugs that antivenoms are expensive to make. They have a very short shelf life, and that the people who need it the most can afford it the least. So it's from a duty to shareholder perspective, it's a bad business case for private industry when they're more likely to make a lot more money off a new Viagra or a new flavor of hemorrhoid cream.
Sure. So if you had to choose to start off with just one antivenom for one type of venomous creature, what do you think would have the biggest impact?
I would actually go for the ones in Pakistan because of the experience I've had there and seeing the suffering that when we were deep in the desert and where some of the people were interested in what we're doing, others didn't want us there. But it's one of these things that you have to start somewhere on the geopolitical scale. And if you can alleviate suffering, then you're going to reduce resentment, which can only aid in peace process.
Certainly. Well, Bryan, I think that is a really important thing for us to think about going forward. Some of these problems that I think are not well publicized that developing countries are facing. So I know we've talked about a lot of different things throughout our conversation today. We've talked about a lot of the people who've encouraged you over the course of your career, some of the experiences you've had. And I think as a scientist, you get a lot of advice throughout your life and career. Is there one piece of advice that sticks out in your mind as just the best piece that you want to pass forward on to our listeners?
Probably one from my PhD supervisor, Paul Elwood, where he knew that I wanted to make my career in Brisbane and stay there. And he said that you have to, if you want to stay, you have to leave, that you need to break the intellectual apron strings, spend time at other universities, including overseas, so that you can be seen to be participating in the intellectual pollination, that you're not just learning new things, but you're bringing new things as well. And that's a very important part. So it's the number one thing I could suggest would be to be very dynamic and forward thinking and plan out where you want to go in order to satisfy that kind of thing. Because if you don't know where you want to go, you don't know what you need to do to prepare to go there.
Absolutely. I think that's great advice. And I think having that kind of endpoint in mind helps you trace the steps that you need to make to get there. Absolutely. So now, can you tell us, Bryan, is there any last note of inspiration you want to leave our listeners with, or any last advice that you would like to give them?
Never give up, never surrender.
Back to the beginning. I like it. It all comes full circle.
Yeah, you know what? Yeah, the wisdom of Galaxy. That use your passion as a fuel. That I would not recommend science to anybody as a career unless you're working in an area that has absolutely seduced you, that you're smitten by what you're doing, that if you had millions of dollars, you'd still be happily bouncing out of the bed. In fact, you'd probably be happier bouncing out of the bed because you're struggling for funding. But work on an area that if you didn't have to worry about money, you'd still be working on. That tells you that you've found your true calling, because there's so much drudgery. There's the emotional roller coaster. There's the uncertain career path. There's the drip feeding nature of the funding. There's all these unique obstacles that don't plague other careers, and that you're not going to get sympathy from other people outside of science who can't appreciate these kind of extraordinary soul-crushing pressures that we can be under, that the only thing that's going to keep you going is your incredible passion and using that as your fuel. Otherwise, you will be ground into dust.
Well, I think that is an important message to leave our listeners with today. Can you tell them, Bryan, if they want to learn more about you and the amazing work you do, where should they go?
First, I'd recommend the scientific textbook, because I published that deliberately, put out the science first before committing social suicide with the memoirs, but then read the memoirs Venom Doc, because it's very entertaining, but it really brings out the human side of science in that regard, not just me, but also some of the things that have happened around me and people I've encountered. Of course, there's my webpage, which is a bit stripped down at the moment, but rebuilding it. It's venomdoc.com. But of course, the most important thing is just still search within yourself and find out what makes you tick as a scientist.
I love it. Well, Bryan, thank you so much for joining us today and sharing a piece of your story.
Thank you very much for having me.
Well, it was a delight to chat with you. And listeners, thank you for joining us today. We'll see you next time on another episode of People Behind the Science. Your voyage to explore the lives of today's exceptional scientists has just begun. You can find everything we talked about today, including our guests' favorite books, biographies, photos, and more, when you visit us at www.peoplebehindthescience.com. I look forward to chatting with you next time on People Behind the Science.